Hi, tonight we're going to talk about three variable systems of equations. This is an extension off of the mystery shaped worksheet that we did because these are a little bit tougher to find. So kind of the goal of these problems when you start is to use elimination to change the 3 by 3 system into a 2 by 2 system. Okay. What I mean by that is right now it's a 3 by 3 system because there's 3 variables and 3 equations. We need to somehow eliminate one variable, and by doing so we can combine these and write it just as a 2 variable, 2 equation system. So how we do that is look for a variable that can be easily eliminated from all 3 equations. So I am taking a look at my equations and I notice that the y's are, there's a positive y and a negative y and a negative y. I could somehow add these equations together and I could use that to eliminate y. So just as an organization tool, I'm going to label my equations. So the first one is equation A, the second one is equation B, and then the third one is equation C. Okay, we are going to first eliminate y by adding equations A and B together. So A plus B. So what that will look like is equation A and equation B and I'm going to add the two equations together. So x plus x is 2x, the y's are eliminated, plus 4z equals negative 4. Okay, I'm going to label this one equation D. We also need to incorporate equation C. So this time I'm going to eliminate y, but by doing so I'm going to use equations B and C to do that. So equation B is x plus y plus 3z equals negative 3. 2x minus y plus 2z equals 0. And I'm going to add those equations together. Okay, so we get 3x plus 5z equals negative 3. So our new system. Our new system is 2x plus 4z equals negative 4 and 3x plus 5z equals negative 3. It's equation D and equation E. Okay. Notice how we started with a 3 variable, 3 equation system, and by eliminating the same variable we've broken it down into a 2 variable, 2 equation system. Now we can solve this just like what we're used to. You can use substitution or elimination. I'm going to use substitution, or not substitution, elimination, and I'm going to try to eliminate the x's. So I'm going to have to multiply the first equation by negative 3 and the second equation by 2. And by doing so, I'll get the opposite sign coefficients on x that will cancel. So we get negative 6x minus 12y, equals a positive 12. And then 6x plus 10z equals negative 6. Okay. Add those equations together. The x's will cancel. Negative 2z equals 6. and then divide by -2, z equals -3. So we found our first variable, z, is going to be equivalent to -3. Now that we have one variable, we can go backwards and find a missing variable. So I want to jump back to that two variable, two equation system, and this will allow me to find x. I can use either equation. I'm going to use the first equation. So that would look like 2x plus 4 times -3 equals -4. Add 12 to both sides. 2x is equal to 8. So x equals 4. I found my second variable. Now that I have the solutions for z and x, I can go all the way back up to one of my original equations that had the three variables and use it to find the missing y. Doesn't matter which one we use. I'm going to use the second equation. Okay, so just to rewrite it, it was x plus y plus 3z equals -3. Our x is 4 plus y plus 3z was -3. Okay. Combining like terms, we have -9 plus 4. That's -5. And then add 5 to both sides. Y is equal to 2. So with an ordered pair, should be the solution whenever you have a two variable, two equation system. Your answer for these should look like an ordered triple. So you always write them in alphabetical order. So that means that your ordered triple should be in the format of x to y to z. So our solution here is 4, 2, -3. And that will be our answer. If you want to check your answer, it's always kind of a good idea to do that. What you can do is plug in that x, y, and z values into each equation and verify that it really is in fact a solution to each equation. So x minus y plus z equals -1. So if we were to plug in our values, that would be 4 minus 2 plus -3. Does that equal -1? 4 minus 2 is 2, minus 3 is -1. Yes, so it's a solution to the first equation. The next one, x plus y plus 3z, we're wondering, does that equal -3? So 4 plus 2 plus 3 times -3. Does that equal -3? We get 6. And then -9. 6 plus -9 is -3. And lastly, 2x minus y plus 2z equals 0. So this is 2 times 4 minus 2 plus 2 times -3. 2 times 4 is 8, minus 2 is 6. So this first part is 6, and then we're adding -6. That does equal 0. So we in fact found our solution and verified that it fit, or that it was a solution to all three equations. Okay, thank you.